Welcome to EDU World Space.
In this question, we have a boy sliding down a slide of length 10 meters, which is at a height of 8 meters. The boy weighs 200 newtons. The first part of this question wants us to work out how much work is done by the ladder on the boy as he goes up. We can easily say that the ladder does not do any work on the boy because the boy is doing work on the ladder, so this is equal to 0 joules. The second part of this question wants us to work out the work done by the slide on the buoy while he slides down it. So this has to be equal to the work done against the frictional force. We know that the frictional force is equal to mu r. We know that the coefficient of friction is a fixed value and r is the reaction force. We're told that the force due to friction is 3/10 of his weight, so it's equal to 60 newtons, because that is 200 newtons, which is his weight, times 3/10, which is 60 newtons. We also know that the work done by a force is the force multiplied by the distance in the direction of the force. So we know that the force is 60 newtons and he slides 10 meters down the slide, and therefore the work done against the frictional force is 10 times 60, because here we have the force and here we have the distance, which is equal to 600 joules. The final part of this question wants us to work out what the work done by the forces inside of the buoy is as he slides down. So we know that this is equal to the parallel component of his weight because it's in the direction of the slide. So in order to work out the parallel component to the slide of his weight, we have to resolve his weight. We know theta is here, and therefore by resolving the buoy's forces, it is equal to theta in here. We want to find out this component parallel to the slide, so we need to do 200 multiplied by sine theta. As we know that sine theta is equal to opposite over the hypotenuse, and it's also equal to this angle in here, we can see that it must be equal to the opposite here, which is 8 over 10. So it's equal to 8/10. As a result, we can say the work done by the forces inside the buoy as he slides down is equal to the weight of the buoy times sine theta to resolve it, multiplied by the distance that this force acts over. So again, this 10 meters. So as a result now, we can say by calculating this that 1600 joules of work are done by the forces inside the buoy as he slides down.